Okay, so we're going to talk about the GM EV Bolt fires. And these fires happened inside the battery pack of GM EV Bolt vehicles. Initially started happening when the vehicle was charging, so the engineers thought, oh, it could be something related to charging too much or overcharging scenario or those kinds of things. But then it started happening even while the vehicle was stationary in the parking lot. And the motivation behind this video is to increase the technical understanding behind some of these issues and to reduce the fear that has happened as a result of it. Now, the customers of GM that have had to go through these kinds of issues may never buy a GM EV ever again. But it's also possible that they tell 10 other, 100 other people that get convinced that electric vehicles are not safe. And I understand the fear and the consequences of such types of events that can really, in this case, burn down people's homes. So it's not a small occurrence that has happened. But we need to learn from this so that it doesn't get repeated. And we also need to spread information about the technology behind electric vehicles so that the fear is reduced. And if you look at the statistics, the number of fires of electric vehicles is still much lesser than the number of fires of ICE vehicles. But they get reported so much more because it's a newer technology that people are adopting. So one thing that goes wrong here and there, it becomes a worldwide event because of mainstream media. Okay, so in this case, the issues happened inside the cells, and these cells were from LG Chem. Now, this issue, what we're going to talk about today, it could happen it's not specifically related to electric vehicles. It could happen in a mobile phone, it could happen in an airplane, it can happen in any product or any device that has batteries. And it actually has happened, not this specific issue, but battery related problems or fires have happened previously in Boeing airplanes, also happened in Samsung mobile phones, right? So this is definitely not a unique event, but it is a big enough event for us to dive a little deeper and understand what went wrong so as to not repeat the same mistakes in the future. Okay, so the two main reasons that were stated by GM for the recall were that the cells had two issues that were found through preliminary investigation. And this is torn tabs and folded separators. So torn tab, and we have a folded separator. Let's understand what a tab is, and let's understand what a separator is. Okay, so a tab is a piece of metal that connects the internals of the cell to the external of the cell. It is a pathway for electrons to flow from the interior of the cell to the exterior of the cell and vice versa, based on if it's charging or discharging. So this pathway looks a little bit different in different types of cells based on the form factor. A form factor, you can look at some of my previous videos to go in detail about cell form factors and what is inside the cell. But a cell form factor, the main types of cell form factors are cylindrical, prismatic, and pouch. In this case, the cells that caught on fire were pouch type form factors. And in a pouch type form factor, let's draw out the best I can do in terms of depicting a pouch type form factor and see what the tabs look like. Okay, so a pouch type cell is most of the times a rectangular type cell. Inside it, we will have still the four main elements, which are anode, cathode, separator, and the electrolyte. That's the four main elements inside any type of lithium-ion cell that we see currently in the industry. And so what have I drawn here? So in black, I've drawn the exterior casing of the cell. This is what you see when you look at the cell from outside. And in green, what I've drawn is a top-down view of the interior of the cell. And the interior of the cell will have, like I just said, the anode will have a separating membrane. And we have a cathode, right? So a cathode, a separating membrane, and then we have anode. Now, all these three are depicted over here. Now the cathode needs, or in this case, the anode is exposed through a tab. And this tab is a metal piece that is allowing the electrons that are on the anode plate to have a pathway to the exterior of the cell. Similarly, you'll have a tab that connects the cathode and allows electrons to flow into and out of the cell, the cathode electrode, to the exterior of the cell. And what are the electrons doing when they're outside the cell? Well, they're connected to other cells in series and parallel to form the product. And this product can be a vehicle battery pack, it could be a airliner battery pack, it could be your mobile phone battery pack, or whatever the product is. So what GM found was that in some cells, not in all cells, there was a manufacturing defect in the tab. And part of the tab was found floating inside the cell. And this could be due to an imperfect connection between the anode plate and the tab that is providing the pathway. So then if there's an imperfect connection, then part of that connection could get loose during the operation of the vehicle. And so during, say, a vibration, the part of the tab gets torn off and falls inside the cell. This could very well happen. In this case, it happened at least. And similarly, it could happen with the cathode. So in what cases could this happen? Well, we just discussed one case in which it's not properly connected to the anode plate. Or it could be that during manufacturing of the cell, a piece of the tab was just found floating inside the cell. And when it went into the cell and the cell got sealed during manufacturing, at that point, things were okay. You put a voltmeter on the cell terminals, it'll still give you cell voltage. But say you have a small piece of metal floating inside the electrolyte of the cell. Now, the cell can be completely fine at this point, but the cell goes through vibration, goes through use, and then makes a cut inside the separator. So the separator is the membrane that physically and electrically separates the anode and the cathode. If this membrane somehow is cut or somehow loses that physical, basically, if there's a piece of metal that is found floating inside the cell, and that piece of metal cuts the separating membrane, then we have a short circuit between the anode and the cathode, right? And when you have a short circuit between the anode and the cathode, you have, inside the cell, you have an internal short. And if you have an internal short, you can't really fuse the cell on the exterior side to stop this. When you have an internal problem inside the cell, then there is a little bit of a bigger issue Because you can't, during the vehicle's operation, you can't go into the cell and start to fix. A BMS can't do that, and no other protection device like a fuse or something can do that from an exterior point of view. Both of these, BMS and fusing and other types of switches that might be used to protect different features and functions of the battery pack, these all are exterior to the cell. So if an issue happens interior to the cell, we have less that we can do to prevent that problem. What we can do in this case is we can stop propagation of that problem from one cell to the other. And that is the effort that needs to happen. In this case, yes, there was a problem that happened inside the cell, causing an internal short circuit of the cell, causing thermal runaway of a cell. But there could be a design, and there should be a design, if one cell fails inside the vehicle, then that cell's failure does not propagate to adjacent cell failures. Okay, so coming back to the issue, this torn tab broke the separating membrane and caused a short circuit between the anode and the cathode of the cell. And when you have a short circuit between the anode and the cathode, you have a large amount of current flowing between the anode and the cathode, which means that the large amount of current causes the cell temperature to increase. And the increase in cell temperature then causes the certain reactions inside the cell that were initially not possible because the cell temperature was within limits. But as the cell temperature increases, these reactions that are exothermic in nature, these get enabled. And this causes a negative chain reaction, which eventually leads to the cell going under thermal runaway. And when the cell undergoes thermal runaway, some of the gases that are emitted as a byproduct of these reactions are flammable. And because these gases are flammable, we have a fire that happens inside the cell, which then erupts, and if the pack is not designed properly, can spread to adjacent cells. Okay, so that's the first problem that happened. We had a torn tab. Now let's understand what the second problem that was stated. What was that? So the second problem that was stated is a folded separator. So we already know what a separator does. So a separator physically separates the anode and the cathode inside the cell. Now, in a pouch type cell, there is two ways in which the cell can be manufactured, and this is stacked or folding. So by stacking or by folding. And what this means is that this is how a pouch type cell is manufactured. So if you think about a rectangular cell, right, and you have these the anode, cathode, and the separator. These are physical electrodes and membranes that you need to place inside the cell. How do you place, if you have a rectangular pouch type cell, how can you place, what are the different ways in which you can place these? And to give you another kind of a point here, these membranes or these electrodes, they come in sheets and rolls, long rolls of an anode electrode, long rolls of a cathode electrode, long rolls of a separator membrane. Okay, so what are the two ways in which we can arrange these? Well, one is through stacking, with which what we would need to do is we would need to, if we have say a long roll, right, coming out of the membrane, we take pieces, we cut pieces, and we stack them. So we stack the separator, we stack, on one side we put the anode, and on the other side we put the cathode. So the separator is sitting in the middle. Let me try to draw that a little bit clearly. Okay, so we have the anode membrane, then we have the separator membrane. And then we finally have the cathode. Okay, hopefully that's a little bit clearer. Okay, and in order to get here, we first needed to cut them into pieces and then stack them. So this is called the stacked type pouch type cell. Okay, so there's one more way in which we can manufacture a pouch type cell, and this is through folding. And what is done over here is, instead of cutting, what is done is, we have large rolls of the separator, we have a large roll of the anode, and then we have a large roll of the cathode, right? And these, if you think about it, so this, obviously the separator is in the middle, and then the anode, cathode are on either side, and they're folded. Instead of separating, they are folded on top of each other. Okay, so if you arrange these three and then you fold and then compress, then you can have an anode, cathode, and separator structure that can be arranged and then finally cut at the end. So what are the advantages and disadvantages of these two types? So what the advantages of folding are that if, in case of stacking, because these are pre-cut, this is, if the separator membrane moves just a little bit, then you can have, say it's offset just a little bit, right? In this case, it's exactly aligned, but say the separator membrane was a little bit offset. In this case, this corner of the cathode might get short-circuited with the anode of the cathode if the separator gets offset a little bit. The chances of this happening when in a folded type scenario is a little bit less, because there's not so many single sheets of anode, cathode, and electrode that you have to stack. You have a folded type of a structure, because of which it's harder for it to for one membrane, in this case the separator, to move and then cause a short circuit. It can definitely happen still in folding if the folding is not done properly, but the chances of it happening at stacking is a little bit more. So what happened here when they're saying folded separator does not mean that they're not talking about the manufacturing stage of folding. What they are saying is that the separator membrane that was separating the anode and the cathode, and it's not stated if that pouch type cell was made through folding methodology or stacking methodology, but what happened is that part of the separator, instead of it being straight, had a little fold inside it, right? So say I remove this part of the separator, and instead of being a square, say it has a fold. Now it's similar to the scenario we were discussing before. Because the separator membrane, it has a little bit of fold, we have a short circuit between the cathode and the anode. And this can, especially combine this problem combined with the torn tab problem, this is what caused the issues inside GM EV Bolt vehicles. So last point I want to make is, what can we do to prevent such issues? Well, these issues, one, there needs to be a better quality assurance on the side of LG and the side of GM to prevent such types of cell defects going from the factory line into consumer vehicles. So say you do everything possible to stop cell level failures, but they still creep into your product. Now, what we need to do as a second level of safety is to prevent this cell level failure from propagating into a multiple cell failure and then propagating to a pack failure, leading to a vehicle failure in this case. So there are strategies that can be put in place. There are products that are available in the market today. There are ways that you can arrange the cells. You can put different types of membranes, different types of protection devices in the way that the pack is arranged. And this is a process through which you can prevent that failure from propagating into a much larger failure. And this is something I talk about in detail in our battery safety course. I'm going to link that below if you are interested in going further. But in this video, what I wanted to cover is the GM EV bolt recall, and then a little bit more, hopefully through this video you were able to get a little bit more technical understanding of what went wrong, so that you were able to prevent such types of issues from getting into your products as well. So if you like this video, make sure to give us a like and hit the subscribe button, and we will be in touch with more such videos in the future. Thanks so much for watching.